We are the Math Scientists, and this is our whiteboard video on boron carbide. Boron carbide is known as the black diamond. It is the third hardest material known to man at room temperature, and it is the hardest above 1100 degrees Celsius. Once formed, it is chemically inert. Boron carbide is used in applications such as control rods and nuclear reactors, since boron has very high cross-section for absorption for neutrons. It is also used in semiconductors and ballistic armor such as bulletproof vests, armored tiles for tanks, and Apache helicopters, since it is relatively low weight and has exceptionally high stopping power. Boron carbide is formed through a strongly exothermic chemical reaction. It ideally forms a rhombohedral unit cell of 15 atoms in a ratio of 13 borons to 2 carbons. The atoms bond in one icosahedral boron unit and then a linear carbon-boron-carbon chain. It is more commonly referred to as B4C because the material is capable of forming a large variation of carbon concentration without resulting in interstitial occupancies or phase separations. Boron carbide structure has been historically difficult to discern because boron and carbon each have very similar electron densities and scattering cross-sections, so neutron and X-ray diffraction studies are not very successful. Boron carbide is a peritectic, meaning the liquid and solid phases react to produce one solid phase of boron carbide. It is located in the center of the phase diagram shown on the board. Because of the variation in carbon content in boron carbide, the structure generally forms a polycrystalline solid susceptible to planar defects such as grain boundaries. One technique for forming boron carbide is the solid-state diffusion between boric oxide and carbon in an electric arc furnace. The reaction produces a boron carbide powder, which is then sintered down and condensed to produce the desired product.